security relating to computers is really no different as a basic concept than security applied to any other field, be it automotive, like car safety. Crossing the street is an issue of security and safety. Not buying a computer, but buying a house, buying whatever it is that you do, you have to evaluate what is the security aspects of that situation, and you have to do a form of risk assessment. So evaluate, okay, what are the pros and cons of this situation? What could go wrong? And what could I do, ideally at least, ask yourself, what could I do to prevent the bad things or reduce the possibility that bad things happen and increase the possibility that the outcome is what I would like it to be, what I expect it to be. What I want to talk about today, or to do today, is to look at how we can move from this risk triangle to be able to do some kind of assessment of risk. Us as IT people, we need to have at least a basic understanding of simple risk assessment techniques so that we can at least do some evaluation. So let's say that we have what we call here the risk triangle. There's three things that have to co-occur for risk to exist. So there's three things that have to exist at a given time and place. This is T and S. In a given time and space that have to coincide for risk to exist. And the E here stands for element. So there has to be an element, something. In the type of car insurance, the element is the car, right? If we're talking about life insurance, the element is you, the thing that may suffer some kind of damage. In IT, well, it could be a computer, it could be data, it could be a business process, anything that is what is called an informational asset. So an asset from an IT point of view is a system, like a computer system, or an actual component of a computer system, like a PC or a hard disk, or a business process that uses computers, or the actual data itself. Because data has value, right? So these elements that we need to consider, and we can decide what it is that we consider to be the basic element. But if we've never done a risk assessment for any of our computer systems, maybe we can take our whole IT department, or our servers, for example, or our computer network as the basic element that we're going to be studying. So at any given time and place, there has to be three things that have to coexist. So there has to be the potential for a hazard or a threat. So something happened, like a hazard. Think of a natural hazard, like a tornado, for example, or an earthquake, right? But also some kind of threat, like a hacker, a criminal. So these are potential threats. And these threats have to exploit a vulnerability. So there has to be some kind of weakness in the system that they can take advantage of. Now for a computer system, that's easy, because computer systems are very complex machines, and they rely on a whole bunch of different input and output ports, right? So these are potential weak spots. If there's an I/O, there's a potential for someone to come in. And if the I/O is located elsewhere, like in a network, well, then there's a potential for someone to come in through the network. Vulnerabilities are associated with software. Software with no bugs does not exist. There's no such thing as software without bugs. So an operating system is the same thing. There's no such thing as operating system without bugs. So a hacker or somebody malicious might write a program that will take advantage of a weakness in the operating system, or if you prefer, a bug. We hear a lot about viruses for Windows. There's a lot of potential weaknesses in Windows, but the reason why we know so much about it is because 90% of all computers out there run on Windows. If I'm going to write a virus, I'm going to write it for Windows, right? There's not much money to be made to write viruses for Macs. or for iPhones, or for Blackberries. Well, Blackberries maybe, because there's a lot of them out there. So, but we rarely hear about viruses for Linux, but it's because there's really not that much money to be made by somebody malicious to try to write the viruses for Linux, unless he's targeting something specific, or unless they're doing a proof of concept. Like if I wanted to make Apple look bad, maybe I'd make it my mission in life to start writing viruses for Macs, for Mac OS.
That
right?
will come.
And there's people who do that. There's people who run a business of trying to figure out vulnerabilities for specific machines. Companies like the big virus makers, they have teams of people who try to identify weaknesses in systems. Of course, they do it in a lab setting. They don't, publish their viruses out on the web, but they publish what's called an exploit. They publish maybe an article that explains what vulnerability they found and how it could potentially be exploited. And this gives Apple a chance to try to patch it. This is why we have service patches all the time. This is why we have Patch Tuesdays with Microsoft. Because there's so many people who, just because they hate Bill Gates or whatever, or because they want to make money, like, Russians, former Russian spies who have a lot of spare time and want to do phishing or do whatever, right? They write viruses and they try to use it to make money. But these exploit vulnerabilities. There are all kinds of vulnerabilities. Some are physical vulnerabilities, like for example, a computer like this one uses electricity. So if I pour water on the computer, it's going to short some of the parts. So this computer is vulnerable to water, right? Right. Especially if it's salt water, because it causes a powerful shock. So there's the potential threat, there's a vulnerability, and it has to result in some kind of damage. Or there has to be some kind of impact, which generally we refer to as a negative impact. We don't care about positive impacts. If it works out, the end result is better than what we had before, we're not overly concerned with that. So how do we get from here to doing a risk assessment? Right? So we said there's three things that have to coincide. There has to be the threat, the vulnerability, and the damage. These three things have to coincide. And these are for a specific E, or an element at risk, for a given time and place. So we need to identify what is the element that we want to evaluate the risk for. Let's say that in this case, it's the first time we do a risk assessment for the company. We're going to do a simple risk assessment of the whole network. And next year we'll do another one. Maybe we'll get better at it and we'll try to go into more detail. But this year, let's just do it for the whole network. So are there potential threats to the computer network?
Yes.
So why don't we mention some? Anyone? Potential threats to our network.
Virus.
So a virus is a threat. A hacker is another threat. Spam. Power outage.
Hardware failure.
And let's do a last one. Hardware failure. So really, if I wanted to make a list of these, all the ones that are most relevant, there's places that I can go to find what are the type of threats that are likely to affect my computer network. Just Google it, right? And you'll find people who publish lists of potential threats. You can also use methodologies, ISO standards. There's a whole bunch of places where you can get information. So for us, we'll keep it simple. We'll limit it to 5. If I wanted to do a real threat assessment of our network, maybe I'd want to identify maybe 40 or 50. At least 20 or 30, to start. Okay? So now the next thing I need to ask myself for all of these, is there a potential vulnerability that might be exploited by these threats? So, for example, a virus. Is there a vulnerability that could be exploited by a virus?
Yes, your information. losing data?
That would be the end result. If losing data would be the damage, right? Loss of data.
Slow down your computer?
Well, slowing computer. These are all damages. These are end results. But we talked a minute ago about weaknesses in bugs with the operating system, for example, right? Like open ports, right? Bugs, and other type of issues that are built into the operating system that may make me vulnerable to viruses. And if a virus gets in, then it will corrupt, it can change data. We talked about the CIA, confidentiality, integrity, availability. So it might affect the confidentiality, it might allow people to see data that I don't want them to see.
Right.
It might affect the integrity, so data that might get changed, modified, so it doesn't have the same value to me. Or it might become unavailable, like, for example, being deleted. So there is a threat, yes, there is a vulnerability, and the potential damage is loss of data. So, and those might all occur at the same time or within a close proximity, right? So this is a real risk. There is a risk associated to that. Hacker. Is there a vulnerability that might be exploited by a hacker? Anyone?
Information. Can you not read your information? Can you not?
Again, this is the impact.
Okay,
Loss
the
of
end result, you want the
data,
vulnerability.
slowing, in this case hacker, we said no access. This is the end result.
The remote control, that would be him too? That would be an end result as well?
That he take control of my machine, yes, that would be an end result.
Okay.
The password is too big.
Lack of security.
So lack of security.
The password is too big, it's okay?
My password is too small,
Too small, right.
or too short, or too simple. Like I use password as a password. I don't know if you guys saw, not that long ago, there was a company that published 30 million passwords. They got a hold of a password file for something, for Hotmail or something like that, I'm not sure. And they published 30 million passwords, and what we see is that some of the people tend to use the same thing as a password. So for example, 1, 2, 3, 4, 5, 6, common password. The word password is a common password. All swear words that you can imagine, in whatever language you can imagine, popular password. So we do this for every type of potential threat that we identify. So once we've identified then the potential, what we try to do, as much as is possible, is to quantify these damages. Put them into dollars, if we can. Or at the very least, if we can't put them into dollar, try to put them on a sliding scale from no big deal to critical. And then try to decide as an organization, how much risk are we willing to take? We're willing to take some risk, right? Everyone is willing to take some risk. If we didn't take any risk, we'd stay home in bed all day long.
Right.
Would be, agoraphobic, would be afraid to get out of the house because we can't accept the risk. So we all have to accept some risk. It's the same for individuals as for organizations. So the organization needs to ask itself, okay, how much risk am I willing to take? What is my appetite for risk, and what is my tolerance for risk? And once I've determined this, and everything that exceeds what I'm willing to tolerate, well, I need to either not do it, right? Or put in place some kind of measure to be able to deal with it. So I know for sure I will have viruses, right? If I take a computer and I plug it to the internet, there was a study some years ago, I think by Microsoft, and it took 15 minutes before the computer got infected by viruses. So, and I know that I'm vulnerable to it, and I know that it's going to cause damages, like lose my data, but I'm not willing to accept that, but I will decide to mitigate it, because the cost to mitigate it is very small compared to the potential damages, right? In this case, I only need to buy a $50 antivirus. Actually, I can get some for free, but for enterprise class, stuff I would have to pay for it. Maybe the equivalent of $40, $50 per seat per computer. So $40 or $50 to protect myself from the potential loss of thousands of dollars of data makes sense, right? And I'm not willing to accept it. So I can't afford, I can't live with having no antivirus because the risk is too high, but I can protect myself at a reasonable price. So the first thing I need to know is what is my risk? So I would do something like this, try to quantify this, put a dollar figure to it, right? That's what I've done. One way that I can do this very efficiently is to use scenarios. Say, what if? What if there was a fire in the building? What would happen? What if there was someone stole one of my people's computers? What ifs, right? What would happen if this scenario? So the use of scenario is a very efficient way to do that. It makes it easy to quantify, to put a dollar amount at the end, because I can go and talk to people and say, okay, we're evaluating a scenario of a computer being stolen. What do you think? What would happen? What would make sense? What do you think? And as we talk about it, we become more aware. And as we become more aware, we become more mature about risk. And then we take better informed decisions. And there's tools and methodologies and stuff that we can use. But really, the best thing is to increase our awareness of security and to try to think, intelligently about what we have to do. So this is what risk management is